Hi, in this video we will go through how to create clear requirements for your specification of requirements, and we'll go through how to make SMART goals. I will present some theory, then I will give you some reasoning behind it, and then I will show you a blank paper approach where I start with a poorly formulated requirement and make it into a better one. So for the SMART goals, let me start by saying there are several versions out there where the different letters mean different things. This is just one way of looking at it. But the general idea is always good, and no matter which interpretation you use, you will get a good result. So SMART, the first letter is the S, stands for specific. So you want your requirement to be specific, because if it isn't, then it's very difficult for you as an engineer to evaluate whether it is fulfilled. Okay, so if it's vague, you cannot evaluate it. So you want it specific. The next thing is measurable. Obviously, if you can't measure it, you don't know whether it's fulfilled or not. So you definitely want measurable requirements. The A stands for achievable, attainable. If your requirement is not achievable or attainable, why would you waste time on it? It doesn't make sense to have requirements that you cannot fulfill. R stands for realistic. If a requirement is not realistic, you should move it to the won't have section in the Moscow. So realistic could be with respect to the budget you have available, could be with respect to the time you have available, stuff like that. If it's not realistic, don't even try to fulfill it. The final one, T, stands for time bound. Can your requirement be fulfilled within the time you have available? If not, as said, move it to won't have. Time bound also says something about whether you are able to estimate the time it takes to fulfill this requirement. If you cannot estimate the time it will take to fulfill a requirement, you should try to split it into multiple smaller requirements that will be easier for you to get an overview over and to estimate how much time will it take to fulfill this. It's about making your requirements operational, that you can actually use them in your project. It's about enabling you to evaluate the degree of fulfillment. And it's also about not wasting time on something that is unattainable or unrealistic, and to make a better project schedule. Okay, I would like to give you an example. And the example I will use is rather poorly defined. It is can be connected to remotely. And then let's try to improve that. So we remember the SMART. The first thing is the S. We want to make it specific. For that, I will use the who, what, where, when, and why. So the who, well, that's the technician. Enables the technician to connect remotely. That's a little better. The what enables the technician to connect remotely to the defibrillator robot. So the where, the technician is in his service car. So from the service car, and where's that? Let's say over the internet. So when does he do it? It's before a service visit. Why does he do it? Well, it's because he wants to check if he brings the correct parts. Okay, so far so good. Let's make it measurable. enables the technician from the service car to connect remotely to check the error log over the internet from his smartphone, iPhone or Android, which is on a 3G or above network, to the defibrillator robot, which is connected to Wi-Fi 2.4 GHz at the customer's location before a service visit to check that he brings the correct spare parts. Okay, so I know this is getting rather long and we'll fix that later. Let's just stick with it. So the next is the attainable part, the achievable. Is it realistic? I will combine these. So an example of something that is not realistic, at least at this point in time, would be a 5G connection. If we had specified that we required a 5G connection, that's not possible because it hasn't been rolled out yet at the time of shooting this video. But this requirement, as we wrote it here, we can probably fulfill that. So it's both attainable and realistic. We'll skip that and go to time bound. Well, for me, this requirement is not really time bound. It's much too large, much too complex. I think we need to split it up into smaller pieces. So let's try that. Enables the technician from the service car to connect with his smartphone, iPhone or Android, which is on a 3G or above network, to a cloud server. Okay, that's at least a bit smaller. Next, the robot, which is connected to Wi-Fi 2.4 GHz at the customer's location, uploads its error log to a cloud server. The error log contains the location of the robot, its type, and a unique error message. Each unique error message enables the technician to create a list of recommended parts. Okay, so now we split it somewhat, and you can see we actually, from that very short, very unspecific requirement, we already got a lot more requirements, and it's a lot more specific and measurable, and also easier to time estimate how long will it take to fulfill this requirement. So these are just functional requirements so far. Of course, you would need later to make smart product requirements. So this is nowhere done, but I will leave it here. And I would like to just give you an example of an associated product requirement. So one thing we could ask is, for example, how fast? So a product requirement could be connect to the server and get the error log in less than 15 seconds. That would be a product requirement. And it's specific, it's measurable. You can easily measure the time it takes and compare it to the requirement of 15 seconds. So this was a blank paper example. It's of course nowhere done. Making a good specification of requirements with all functional and product requirements, it can easily take a whole week. It can easily fill several pages. I've seen product requirements of 15 pages. So it's something you should be aware of. This will take time, but the time you spend here will make the next phase of your project go a lot easier. So it's worthwhile to make a good, full, and operational specification of requirements. Thank you.